So this is the assignment which we will be attempting today. It's a very important assignment in the sense that it takes us through the process of cleaning up assembly drawings. When we have very simple assemblies, then obviously the drawings come out very nice and clean. But when we have slightly complicated or more involved assemblies, then some sort of cleanup might be required. And the whole purpose of the exercise is to take you through those steps which you will need to take in those cases. Now, what you're supposed to do is in this exercise is actually to create this very small model over here, which is shown over here under the setting out viewport. And this corner column is the column we will draw as an assembly. So we will model this very quickly. If you notice, it's just the corner column over there. It's an HEA 400, and then it continues as an HEA 400 on both sides. And the length of the column, the height of the column is 8 meters. And from the two sides, from the web side, we've got 4 connections coming in like that. You've got a beam connection. If you zoom in, you've got a splice connection with the bottom column. Then you've got the beam stiffened end plate connection, as well as a vertical brace corner bolted gusset connection. So it shows over here. The same thing repeats itself over here, another beam and another vertical brace coming in, and they're connected. Then if you go further up, both of these are actually braces. These are all back to back. This one and this one are back-to-back channels, and they're both connected using the bolted gusset connection. And then finally, there's a stiffened end plate connection over there, and there's a bolted gusset connection coming from the other side as well. As far as this side is concerned, this plane is concerned, there are girts coming in, shown at the given distances, starting from 750, then 1245, 1245, all the way up, and the last girt is 1025 below the top of the column. And in the middle somewhere, there is this beam coming in, which is connected as a with a haunch connection. So it's not going to take us too much time, maybe a couple of minutes only. And the numbers have been given. These beams on this face are at a distance of 700, 2000, 2500, 2000, and then you got 800 left at the top. All the dimensions are given. So we will quickly model this little structure, and then we will number the model and then create the assembly drawing for this corner column. And once we create the assembly drawing, then actually the purpose of this tutorial will start, which will be that we will follow these steps. We will make some changes in the settings. So it says, watch the tutorial before attempting this. Create the model. We discussed that. Number the model and create the assembly drawing. And then we will change the settings of that assembly drawing. We will, obviously, it's a detailed topic, but this is supposed to teach you some of the things. So we'll make changes to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 settings over here. So we'll change the scale, we'll change the collapse settings, we'll change the annotation styles, we'll change the placement settings for the annotations. We'll change the settings for which views we want drawn. We'll change some dimension related settings. We'll turn on the keep manual changes. All these changes we'll make in the settings. These are things which are commonly used. And then once we've done with the settings and we can't seem to improve the quality of the drawing further, we'll continue with the cleanup process, and we'll do these things over here. We'll move the single part views out of the way. We'll rearrange some front and top views of the assembly. We'll add some 3D views. We'll move some annotations to make them look clearer and cleaner. We'll take an extra section manually. We'll dimension some views manually as well, etc. So the whole point of this exercise will be to learn the process where you will, which will teach you basically how to clean up slightly complicated assembly drawings. So let's quickly create this model now. Let's begin by entering this main column which we will draw. It's an HEA 400 and the height is 8 meters, and there's one continuing after that and there's one under that. So we go to the model, we've set up the grid, we'll just go to the column command, we'll enter the column like that, double click on it, go over here, say 8,000 and make it HEA 400 like that. So the column is there. Then we can enter another column over here and make it match with this one. And then we can enter another column over here. We can just move it down 5 meters, I think the default height was, like that. And also make it the same as this one. So we've got the basic columns in now. In this plane, we have one IPE 400 coming in at a height of 700 from the other side. So we'll let's just quickly put a column over here as well. Make this one also 8,000. And doesn't matter what the profile of that one is, because we'll be focusing on these for the moment. We'll put an IPE 400 over here. Let's just confirm that it's an IPE 400 at a height of 700 from the bottom of the column. So we'll just move it 700 from there, like that. Go back, then we have another copy of that at 2,000 and another copy of that at 4,500. This one is different. So 2,000 and then 4,500. So we select this one, we say copy 2,000 like that, and then 4,500 like that. So we've got the two IPEs inside. And this middle one is actually a back-to-back channel UPE 240. All these braces are back-to-back channels UPE 240. So and this one is at height of 2,500 from the first beam. So what we can do is we can go back in there, copy this linearly 2,500 up just to create it. And then we can actually bring it to the middle because like this, because this is a brace, and we'll turn it into a vertical brace, and we will go and make it a twin profile like that and turn it into a back-to-back channel. It was, if you remember, it was a UPE 240. So we will say UPE 240. We'll give it whatever the distance between them can remain 10, like that. So we have those now. Now let's see, we've got another one of those like that with a horizontal distance of 2,000, and then another one with a horizontal distance of 2,500, and then another one with a horizontal distance of 2,000 as well. So what we will do is go back to the model like this, go to our vertical brace commands, make sure we snap into the finite element point, then hover over this point and say DX 2000 like that. And then once again, we can hover over this one and say DX 2500 like that. And then hover over that one and say DX 2000 like that. And then just make sure all of them are, select all of them, say right click, match elements to this one, so that all of them become the same as that one. Now that's basically this side completed. As far as the other side is concerned, so well, there's one more actually over here, but we'll get to that in a minute. On the other side, we've got these braces, these girts rather, coming in from the other side. So we need to create a column for that. So what I'll do is I'll just create another column over here, give it the same height, 8,000. And then what we can do is we can use under the structural members, there is the create girts command over here, which we can use to select this column and then this column and it's going to create a default set of girths. And we can go back to the drawing and see that the first one is at a distance of 750 from the bottom, and the last one is at a distance of 1025. So 750 and 1025. Let's go back to the model. Let's select the macro, press M, enter. Over there, we can enter 750. And over here, we can enter 1025, I guess, like that. And then we can see that these ones have now been entered according to that. Now we notice that from in this plane there is this beam coming in, which is connecting like a haunch with the haunch connection over there at a height of 4,000. So we can easily enter that. Let's go to a beam command over here and just enter. Let's see what the profile is. The profile is the same. I think it's IPE 400. So we can just move it up 4,000 like that. This one will be connected with a haunch with the column, and the last element is this little one sticking out, which is at a height of 250 millimeters from the top of this beam, and you can choose any length for that. So what we can do is we can enter the beam command like so, and say DZ 250 from there, like that, and then from there we can what we can do is we can, or rather we can just enter it like that, say like from here to the X minus, let's call it just 1000, like that, and then we can just move it up to 50 like that, and then just make sure it is the same as you right click and you say match elements to this one so that it's the same as that one. So basically all the profiles have been entered now, and now we will quickly make the connections. So let's begin by making the splice connections. We will use this video is not meant to teach the macros in detail. I'm going to just use them. So just use the splice connection over here and select this bottom column and our column, and then we'll make some changes to these. We'll select anything created by the macro, press the M key, which selects the macro in the background, and then press enter, and the macro will open. And now we will write a few things over here. Over here you can write 2 into 60 for those bolt distances. Over here you can write 2 into 80 for those bolt distances. Over here just write a 0, and over here you can write 100. And when you do that, if you say apply, you will get the modified connection. You can change the diameter of the web bolts by coming over here and choosing a web bolt assembly. Let's choose this one, bolt diameter of 20, like that. And this is basically what we want from this connection. And once we're happy with that, we can use the same connection over here as well, and just select this macro symbol, this one, come down over here, right click, say match elements to this one, and the other one should also have been modified now. Now let's make the stiffen end plate connections between this column and these beams over here on this side. So we just go to the beam to column connections stiffen end plate, select the column, select the beam, right click, and it's going to give you a default connection unless you have your preset set up. Select anything, press M and enter, and come to the bolts, and over here write 3 into 65 to get some more bolts. Say apply to see, okay, that looks okay. You can say set as default if you want, and then you can do the same over here, right click, and over here and right click as well. That will basically give you the stiffen end plate connections which we want. Now that we have those in place, these connections in place, we want to make the corner bolted gusset connections for these. But before we do that, let's just make a little change. Let's select all these vertical braces like that and press enter and go to the detailing definitions tab over here. And under the capacity ratio, let's enter 0.5. This basically, I'm just showing this as as extra information. This will allow the macro to kind of pre-design those connections for you with roughly a capacity of half the capacity of that element. So let's say okay. So we have those in now. Now we can go to the bracing connections and go to the corner bolted connection over here. Zoom in here, select the column, select the bracing, and then select the stop stiffener like that. And it's going to make the connections. Once again, do the same over here, over here, over here. There's no other brace over here. So basically that's it. These two will be connected. If I right click and come out of it now, this one over here and this one at the back will be connected using the bolted gusset connection. So let's choose the column, then select this one and then this one and right click. That's going to create the connection over there. And now we can focus on the connection of this vertical brace coming from the other side. So for this, we will once again go to the bolted gusset connection, select the column, select this brace, right click. It's going to create rather a largish one. So you select the plate, press M and enter. I want to make these sides a bit smaller so that they don't clash with the splice connection over there. And so I come to the figure tab over here, and over here I say 150 to make these distances smaller, say apply, and that kind of seems to do what I want done. And that's I've basically gotten the connections in on this side. Now I want to do the connections for the haunch over here. So I can go to beam to column connections over there, select the haunch, select the column, and then select the haunch like that. That's going to get that one finished. And now I want to do the connections between the columns and the girts. So I'll go to my purlin and girt connections, select the girt option, select the column, select this girt, right click. This is the one I want. I'm okay with it. Select the column, girt, right click, select the column, girt, right click, column, girt, right click. Of course, there are much faster ways to do this. I'm just showing this quickly now. Like that. And we're basically ready. I think we don't have anything left. We have entered everything which is needed to. So if I were to select this column right now and right click and say select assembly like that and say show only, you can see that this is what my assembly will look like when I draw it. It's not extremely complicated, but it's got a few things on it. So it might need some minor cleanups. And we'll basically, the whole purpose of this tutorial is to teach you about that. So like I said, this is the assembly which we will be drawing, the assembly drawing, and we'll be cleaning it up as well. And there are several ways to do that, but this video is not about creating the detailed explanations of all the options which we have, but we will go through some of them. So normally what you do is once you're done with the modeling, the first thing you do is you do your numbering. And for that, you come to the drawings and reports menu over here. You come to this sub menu over here, you open it up and you say perform numbering. When you do that, it will open up the numbering dialog box. Once again, this video is not about this process, but this is explained in some other videos. All you do right now is just say apply and start numbering. And it will say numbering completed. Say OK. It's going to come back to the model, say close. So now the numbering is done. And we're just going to create a default assembly drawing because the whole purpose is to teach you drawing cleanup. So whatever bad settings we have right now, we'll start with those, then we'll modify some of those settings, and then from after a certain point, we will do the rest of the things manually. So you just select the part. We can select any part. It doesn't have to be the main part of this assembly, but any part on that assembly, and right click and say come to create drawings. Over here we have option of single part drawings, assembly drawings by prefix, which is the one I'm going to use right now, and then drawing creation wizard as well. We will not be touching on this. This is a separate tutorial. But this one allows you much more flexibility and last minute changes, and you can much more powerful than the by prefix one. But right now, this is not our concern. By prefix one will basically check the prefix of this assembly. So let's double click on that. This one is CL. The assembly prefix is CL. It's CL3 at the moment, the actual number. Your number might be different from my number because it depends on the order in which you model these things. But it'll check that prefix, which is CL, and based on that prefix, it's going to select some setting somewhere. We don't really care about that right now because all we want is just to create a drawing and then modify it. So what we'll do is we'll just right click, go to create drawings, and say assembly drawings by prefix. And then it finishes it off. If I double click on the drawing manager over here, you will see that a drawing has been created. This is the one. If I double click on that, you will see that a default drawing has been created. Now this default drawing looks quite different from the ones we are targeting. We're targeting something clean like this. Something like this. Without this, obviously, this is just a setting out information. But basically, we want one view, one main front view and one top view over here. And then we want a couple of 3D views, and then we want the single part drawings, and that's it basically. So we want a much cleaner looking drawing than the one we have right now. But this is what we have, and this is what we will work with. So now that we have the drawing, the basic drawing out of the box, if you will, let's go and make these changes in its settings. This is what we have in the tutorial. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 settings to change. So the first one is change the assembly, change the scale of the assembly and single parts to 7, 1/7. So first of all, how do we get to the settings? So let me go back to the drawing. And if you double click anywhere in the drawing, not on the viewports, anywhere outside, you will open the basic drawing properties dialog box. And inside this, there is this little button called macros. And this is the one which contains the assembly macro settings. So if I click on that, you open this box again. You can have more than one macro sometimes, but this is an assembly drawing. So this has one assembly drawing macro inside. If you double click on this one, you will actually get to the dialog box from where you can make the changes. And over here, maybe you've seen this elsewhere in some other video as well. But the drawing on which we have double clicked, the existing drawing, the one we want to change, its settings are always inside. You need to click on this default button over here. When you click on this, you will get to the settings of this particular drawing which we have. So with this dialog box open, we can start making the changes. Let's go back to the drawing. The first thing it says is change the scale of assembly and single parts to 7. So if we come over here, there's the general tab, the views tab, the dimensions, the annotations and display, layout, presets, etc. You go to the general tab, and over here we have the assembly scale at 10. I'm going to change it to 7. The profile part scale to 7 as well. And the plate part scale to 7 as well. Maybe I can leave this one because it doesn't require that. I can leave that at 10. And this one is what my requirement is. After that, it says change the collapse settings to 25 and 7. This one over here. Go back in there. Over here, you see the profile collapse settings, the assembly drawing collapse settings, and for profile parts and plate parts separately as well. So it says 25/7. I'm going to make this 25. I'm going to make this 7. Let's just confirm that. 25/7, yeah. For the assembly, for the assembly main parts, and for this one, I can make it 25 and 7 again, because these are basically to do with when you have long parts. So this particular column is about 8 meters long, and with a scale of 1:7, it's going to be almost a 1 meter long drawing, a little more than that even. So it's not going to easily fit in if you don't have any collapse in the X direction. It's not going to fit in the even in an A0 size drawing. So these will allow it to, wherever it sees inactivity in the drawing, it'll basically collapse that. I'm not going to change the plate settings. They're fine. Let's go back in there. Then it says change the annotation style to style 2 with baseline. This is to do with the annotations. So let's go back in there. Let's find the annotation display settings, and here we'll have to do a little bit of work. So we'll need to change the annotation settings for frames, for plates, for bolts, all three, remember. And for both the so for frame, there are annotations in the for assembly and also for single parts. Similarly for plates, for assembly and as well as for single parts, and for bolts, which are part of the assembly, and bolts which are shown in the single parts, like that. Now, so we go into these one by one. Let's see what this one has. No, this is not the one. We go into these fields one by one, and we have to go in here to annotation settings. And it says, if you remember, it says change it to style 2 with baseline. So we'll go back in, we'll choose style 2 from here, and we'll extension line and baseline, basically they go together. We'll say apply, okay, and we'll say apply, okay. Then we'll go into this tab. Of course, when we are done doing all this, we'll save this all away with a name, so it's easy to do. I'm just going through the whole thing so that you realize what needs to be done. All these annotation settings for the different situations will need to be changed like that. Apply, okay. Then we go into the plate annotations, go into annotation settings, choose style 2, choose the extension lines, apply, okay. Apply, okay, sorry. Plate annotation for parts, once again go in there, say style 2, choose these two, apply, okay, apply, okay. Now for the bolt annotations for assembly, we go in there, we say style 2, this one, apply, okay, apply, okay. And for this one also, we go in there, choose style 2, this one, apply, okay, like that, apply and okay. So we basically changed for all three. I'm not going to go into the weld ones because in a while we'll see why. Let's go back in there. So we've done this. It says change placement settings, change the placement settings as shown in the tutorial. So I'll just show what I mean by that. And this is to do with the annotations turning out like this. You see this P42. This is what we call style 2, but it could also have been without these lines, and it could just could have just said P42 right in the middle somewhere over here. So when we want the call out to be like this, then the placement settings need to be modified so that they have a certain start value. You see, normally these annotations would start with a 0 distance, and they would try to go all around the plate and see if they can find a place around the plate lines. And you could see, for example, it's saying P42 over here, or in a vertical way or something. But if you don't want that, and you definitely want a call out like this, then you would do the changes I'm going to just show you in a bit. So you go in there. So let's see what it said. It said change the placement settings as shown in the tutorial. So once again, we'll go back in there, and this time we go to these three over here. The frame placement, we go in there and we select this profile. This is a built-in setup, so you can use it. You'll find this in your setup as well. Profile annotation for assembly drawings, and say load. When you say load, certain things will change. There are certain parameters: inner, forbid inner, stuff like that, which makes it and a starting point, auto delta and a starting point, some inside options or whether they've been all set up. When you do that, that kind of makes sure that your annotations look like that. You do the same for plate annotation. You select that preset from there. You say load, say OK, and you do the same for the bolt annotation. You select the same one, say load, press OK. That's basically it. Now you go back to the drawing. The next one, it says draw only the front and top views. Now this is to do with this is the front view of the assembly, and this is the top view of the assembly. You know, you can have a top view, a bottom view, a left view, a right view, a front view, and all that. So we only want the front and the top views according to this requirement. So the front and the top. So we go back to the drawing, and we come back to the views this time over here, and we say I don't want the I want the front view. Let's turn all of these off. So which one was it? We want the front and the top views. So we want the front and the top view. So we can turn these two on. That was the requirement over there. Go back in there. It says select do not dimension. So since we're going to do the manual, now the dimensioning over here, it doesn't mean the dimensions of the single parts will disappear, only the dimensions of these two viewports, which are to do with the assembly itself. They will be removed, and the user will need to do the dimensioning manually. So let's go back in and see where it was. It says select do not dimension. So we go back in there. We go to the dimensioning tab over here, and you can select this one, do not dimension assembly viewports. This one over here. It's fine. Then it says check the keep manual changes option. This is to do with, because we're going to be doing a lot of manual changes, and every time there's an update, let's say we sort out this drawing, we clean up this drawing, and it's eventually make it look nice and good. And then there's a revision, and let's say there's an added stiffener or something changes or something is modified. You don't want everything you did manually to be lost every time, because the macro is going to update itself and it's going to basically redo the whole thing. And we'll be doing some manual changes like adding dimensions and maybe moving around the annotations to make them look cleaner, etc. So you want those to keep their place next time. So this is for that basically. This check the keep manual changes option. We go back in there, and that's probably over here under the views tab. It says keep manual changes. You can turn it on, keep manual changes. Then go back in there. It says change the dimension accuracy to a round number. So we want the dimensions to be kind of round numbers, like we see over here. No 50.5 or something, just all round whole numbers. Let's say that's what we want. So for that, we'll go back to the drawing, and this time we'll go into the annotations and display. And under the dimensions tab, we see a settings over here. And inside the settings, you've seen these elsewhere as well, but this is the only thing I'm changing right now is the format from this one, which is 1 decimal place if it exists, to no decimal place, just round it off to the nearest millimeter. So this is the one I'm changing. I'm saying apply OK. Let's go back in there. Select do not dimension, change dimension accuracy to this. Then uncheck bolt hole annotations in assembly views. So I don't want in the assembly views, these are the two assembly views, this view and this view. So while in the single part views, we do have bolt annotations. Right? You can see that these hole annotations rather, we do have the holes annotated. This is 26 millimeter holes or whatever. But in these views, we don't want to unnecessarily create, in the assembly views, I mean, this one and this one, we don't want to create an unnecessary clutter because this information is already available in the single parts drawings. So all we want over here is just the dimensioning to show where this particular part will be welded. So we don't want unnecessary clutter over here. All we need in these drawings is the annotations of the parts and their dimensions, basically. So what it's saying is, come down here. It's saying uncheck the bolt hole annotations in the assembly views. So I'll go back in there, go back to my annotations, and over here in the bolt annotations, if I go to the assembly, under the assembly one, under the fields, it says even in those two viewports, it's going to, normally it would have created the diameter and the length. I'm just going to select this and move it up so that there's nothing left over there, and say apply and OK. And now it won't annotate the bolts in the assembly viewports. In the single part viewports, it's going to annotate the whole diameter. So that's done. The next thing it wants is change the dimension. Okay, we've done that. And then it says turn off welding annotations. We don't want to create clutter. Let's say we are doing a project in which we have a separate drawing to give notes on welding, or maybe we're just going to do the welding annotations ourselves, perhaps. So we turn this off. And to do that, we go back in. We come to the weld annotations, all the way to the right, and we uncheck this. So we don't want any welding annotations to be shown on the drawing. We go back in, and that one's turned off. And the last one is turn on do not take sections. Now, this has to do with the fact that there, in the background, you can't see it now, but there were many sections. There was a lot of clutter, and I don't want any sections to be taken extra. If needed, I'll take my sections myself. So I go back to the views tab over here, and I say no subsection view. I turn this on, no subsection view. So with all these changes, what did we do? We changed this. We chose these. We added keep manual changes. We changed the scales. We changed the collapse settings. We said do not dimension. We changed the placement for the frames and plates and bolts. We turned off the annotation of the welds. We changed the styles, the style to and the leader line and everything for the annotations. This is what we did. And once we're done with that, we can say OK. So we've done everything. We can say OK. And once we say OK, now if we say execute, if you press this execute button, this drawing in the background, the macro which created this drawing, the macro which created this assembly drawing, will be rerun, and it's going to recreate this assembly drawing based on these new settings. So I'm going to say execute now and see what happens. So we see that it's done, and if I press OK and OK, you see that's already a lot cleaner, a lot cleaner. We've achieved the undimensioned top and the front and top view, and we've also have these single part drawings over there. We don't have the 3D views in there, but it is basically a lot cleaner than it was. Now, immediately I've noticed a slight difference from my drawing over here, from this one over here. In this one, if you notice, there's a splice connection at the start and there's a splice connection at the end. And it has to do with how I use the splice macro in this tutorial. When you select, so if you select this column and then this column, these plates, which you see, can either be shipped as loose plates with their own assembly numbers, or they can be a part of the assembly depending on what you choose. Both options are available. And when you choose that they become part of the column, in that case, the order of selection of the column, so which column you select first, I think becomes the main part for those plates. So in this one, in the one we're doing in the tutorial, we have made the selection in the splice macro in such a way that the plates have gone to the other column, so we don't see the plates over here. But that doesn't really change the whole idea over here. Doesn't change what we're trying to explain over here. So don't be surprised that why don't we have the flange plates over here. It all depends on how you the order in which you select the columns when you're using the splice macro. So that's one thing we can get out of the way. Now, we did some work over here. We probably spent around 5, 7, 10 minutes over here changing these settings. Obviously, I was explaining them as well. Otherwise, it would just take 1 or 2 minutes. But we don't want to spend those 2 or 3 minutes every time we have a similar situation like this. So what we want to do is that for similar columns, kind of longish 8, 9 meter columns, with this kind of structure in them. We want to use these settings from now on. So we want to save away, that's what the tutorial says, save away these settings with a name so that you can use them again in similar situations. So for that, we go back into the drawing, and we just double click anywhere on the drawing, like I said, go to the macros button, double click on this one. And once again, the default one is the one representing our current drawing. So we click on that. These are our current settings, 7, 10, 10, 25, 7. You remember all what we just did a moment ago. You come to the presets tab at right over here, and you can click on the Save As button, and you can give it a name. You can say long columns with lots of plates. Just give it a name. It doesn't really matter what name you give it, as long as you have this preset saved away. So whenever you see a similar situation arise, you can use this. You can override the prefix related settings with this one, and we can talk about that in a separate video. But we can, the point of this part of the tutorial is to let you know how this is done. So just give it a name, and that will be now saved in these settings. Once again, these settings are all saved in the local folder, and you can put them away in your environment folder like we've discussed elsewhere in other videos as well. So we've done that. Okay, we don't need to press the execute button. The macro doesn't need to run. We already have it. So we've basically done what was needed for this step. And now we'll be starting basically the cleanup, which will be composed of these 8 or 9, whatever, 6 or 7 steps. We'll move the single parts, we'll rearrange the front and top views, we'll rearrange single part views similar to the whatever. We'll just go through this one by one. But basically, we are now ready to start this cleanup stage. Now, if you think about it, this is actually where the cleanup starts. Normally, everything we've done so far is either part of the modeling process or defining settings which will be used to create drawings. And if you have these settings stored away, then you will get this drawing with one click, what we have right now. So the cleanup part, which is the part we're interested in, which means moving things around, cleaning up the annotations, finding better places for them, dimensioning manually, those kinds of things. That process is going to start now from this point onwards, and we should be spending maybe perhaps about 5 to 10 minutes on that, not more. Ideally, in an assembly of this complexity. But basically, just wanted to repeat that up till now, whatever we've done is basically just modeling the structure and then changing the settings. And like I said, these settings will be available from now on, or should be available once you set up your system accordingly. Now, the first thing which it says regarding the cleanup is move the single part views out of the way. Now, if you go back to the drawing, first of all, you will see that the single part views, the viewports themselves are color coded differently. So these are color coded yellow, whereas the assembly main part is color coded differently, and the section is color coded, top view is color coded differently. So what you can do is, if you want to, if I want to just move away all the single parts, one way of doing it would be to select them like that, pressing the control key or whatever, or doing window selections like that. But it's time consuming. So what you can do is you can just go like that and press enter. And over here you have viewports, and it's telling you that you've got one steel assembly section viewport, one steel assembly viewport. So the steel assembly viewport is the front one, the main view, and this section is the top one. And then it's got 16 single part viewports. So if I just select this one, automatically my single part viewports are selected, and I can just go like that, and they're moved out of the way. So it's like an easy way to get what you want done faster. Let's go back over there. Then it says rearrange the front and top views in the middle of the page and align. So what it means is, because they're somewhere over here at the top right now, it wants me to move these two views like this, somewhere in the middle of the page, and align them as well if I happen to misalign them during the movement. So I'll go back in there. I can select them like that, bring them. Let's see what they look like. So it's It's taken a section over here which won't be needed because we don't have the splice plates in this example, but fine. All it wants is basically to leave some space on the left over here to insert these two 3D views as well. So I'm just going to bring them roughly to the middle, like that, perhaps. And to make it exactly like the drawing, this view is at the bottom and that view is at the top. So what I'm going to do is I'm going to bring this view at the bottom like that, and then select them both and bring them somewhere, something like this, maybe. So that's basically what the requirement was. Now it also said to align them. So for example, if I've slightly, let's say if I go inside, press the control key and slightly misalign them from each other, what I can do is I can select both of them, go to the tools menu over here and says align viewports. And if I click on that, then the two are aligned to each other once again. Now let's go back in there and see what the next requirement is. It says rearrange the single part views similar to this drawing. Now, of course, you don't have to follow this to the letter, but what it's basically saying is put some of the single part views at the top over here, like it's shown over here, and then put some of the single part views at the bottom, and basically leave this much space on the left for the 3D views. So what we can do is we can come back in, we can maybe select a few of these views like that, put them in there. Select these like that, put them in there. Maybe, I don't know if this is going to work, but maybe this works as well. If you zoom in, yeah, it's kind of working. I can put in these views over here if I want to, like this, like this, like this. Maybe bring in these over here. Maybe, I mean, we've got a lot of space, so that's fine. So I've rearranged the views. Actually, I can, if I wanted to, I could leave a lot of space over here. Maybe I can even bring the size down of the drawing, but I need the space over here. So a little part of the drawing will be empty. I can maybe just move these a bit to the left like that as well, like that. Okay, so this is what the rearrangement basically meant. Rearrange the single part views, add 3D views with different names, and use group filters. So I need to add two 3D views, which kind of look like this. One which is looking at from the direction where the GERT connections are visible, as you can see over here, and the other one is looking at it from the other direction where the beam connections are more clear, because it's going to ask us to annotate these plates over there as well, so that it's clearer for the manufacturer. So two 3D views, one from each angle, they need to be added. And it says use groups. So add 3D views using the group filters. So there are different ways of doing the same thing, but this particular assignment wants us to use group filters. So we're going to try and do that. Now, to do this, I'll go back to the model, and to go back to the model, I can click on this little button at the bottom right over here. When I do that, I'm back in the model, and the assembly is what is showing over here, and that's what I wanted. Otherwise, you could just select assembly and show only. And now what I want to do is create groups over here. So if you come down over here, you see there are groups over here. And if I right click and I say create group, and if I say column, give it a name, column assembly, give it any name like that. So it creates an empty group. And now what I need to do is select everything like this. Make sure you selected the holes and everything and all the parts. And then click on this button at the bottom over here. Click on that one, and then drop it onto the column assembly. Click on the column assembly, and you see that 64 parts have been moved into that group. Now we needed two, so we need this view and this angle of the 3D, and then we also need kind of this angle of the 3D as well. So let's start with this one. Let's find an appropriate angle for yourself, and when you like it, when you think this is a good angle to have, just leave it over there. Go double click on the drawings over here, double click on the drawings over here and click on the 3D, right click and say create viewport. When you do that, a viewport will be created over here like that. Double click on that, go to the filtering option over here, go to the filter settings, and in the groups tab over here, select the column assembly, this one, like that. And then you can go to the general tab over here, and in the draw mode, you can select hidden line, like that. Zoom in to see if everything is okay. So we don't want to see the bolts, we want to see the holes. So if you double click back in, go to the detailing menu and say holes only, and say okay. Okay, that looks more like it. And now I want to change it because it's a bit too small. I want to, if I double click on that, I can in the general tab, I can change the scale to 1:10, say apply and fit. Give it a name of, so it has a name of 3D view. I want these two views to have different names, like 3D view 1 and 3D view 2. So I go back in there, I go to the general section, I call this 3D view 1, like that, from the name section, say okay. So it changes over here as well. Bring this a bit closer, like maybe I open it a little more because I'm going to be doing some annotating as well, like that. And then just pick it up from there and move it to this corner over here. Now, once this view is in place, I can go back to I can click on this button over here and rotate. I'll go back to the model and rotate it and bring it to the orientation which I want, like this. This is the other orientation which I wanted from the back side, which is showing the girt connections. And then double click back on the drawings and just create another, click on the 3D view over here, right click and say create viewport again. And basically go through the same process once again. I say filter settings. Once again, I only want to see the column assembly. I only want to see hidden line mode. I want to see holes only, like that. And I want the scale to be 10. Say apply and say fit, like that. And one thing I forgot was to call this 3D view 2, like that. And bring it up, bring it in like that. Move it to the left-hand side. Make sure it doesn't go out of the page. And basically, we have managed to bring in the two 3D views. If we go back in here, it says add the 3D views with different names using group filters, and that we've just managed to do that. Now, the next thing which it wants us to do is to move the annotations of plates to make them clearer. And so if I go back over there, normally the annotations in the single part views won't need, but it's only in the main assembly views where you might feel the need. So for example, this typically happens in places like, for example, this is saying P5, but it's not really clear which one is it this stiffener, which is P5, or is it this plate, which is P5, and this one is P7. So this P7 is probably much clearer. So if I select this P5 and if I move it like this, this is probably a better place to keep it. What is this P6? I don't know. So it's probably the stiffener over here. What is this P7? If I bring it out, it's actually the outer plate. And this P5 is probably clear. So things like this. What is this P9? It's actually this one. What is this P11? It's actually this one. Stuff like this you might want to do. Just pick it up and just move it. You see, so in some places you'll find that there's a problem. It's not a problem. It's because of the collapse settings, because so that area is not available. So you need to avoid those areas basically. You need to move it in such a way that you don't come on top of those areas. But other than that, so once again, you can select this one, put it over here. You can select this one, put it over here, just to make it clear which particular one it's pointing at. So this is what is meant by moving them around a bit so that you have more control. These ones, you might have a situation like this where it's not really clear which one is which. So this one is probably a better way. This one is clearer now. This one is now clear, and this is probably, or this is probably clearer as well. So things like that. When you're moving the annotations around, just to make them actually, this is not going to be a fatal problem as far as the shop is concerned, because obviously you see all these single parts over here. But a good detailer, a good draftsman will always try to make a better presentation as such, so that the work of the more we try to make it easy for the shop, we make their so the more the drawing is self-explanatory immediately, the better drawing, the better work we've produced. So it's not a bad idea to spend about 2 minutes moving these. It's just two viewports over here if you think about it. If you go through all the annotations, it's probably going to take you about two minutes or something like that. So not doing that and doing that may not be that important, but the shop will thank you a lot more. So this is what was meant by move the annotations in the plates to make them clearer. Now, we're not going to do this because the splice plates aren't really available for us, but we're going to dimension the main and main assembly views manually. And for that, once again, we can start off by, so we can go to the dimension command over here, and we can start, let's do the horizontal dimension. So we can say, let's start from here, and we can give a dimension to this plate like that, like this. And then we can double click on that, or let's right click and say add point. And to add the point, we can maybe add this this location of the bolt for this plate, like that. And then we can add this point over here, like that. And then we can maybe turn it into, double click on that and turn it into a tail dimension, like that, so that we have a reference point, and then the 299 cumulative numbers like that. Right click on that, say add point, and over here we can choose any two bolts if we wanted to, maybe this bolt and this bolt, and then continue. This one doesn't really need to be dimensioned because it's touching the web. Touching the web, once again, it's at the end, so no need to unnecessarily dimension things. Add one over here, add the bolt dimension of this plate over here, add this dimension over here, go to one of the bolts, go to the last bolt, go to the other bolt, continue. This one is on the single part, so it's not really needed. I'm not dimensioning intentionally the girts. I'll just put a separate line for them. For this one, I can basically do something like this one and this one. And once again, I can click on this point, this hole, this end, like that, and basically just clean it, finish it up with the end. Maybe I can just move these viewports a little out of the way, make this a little wider, and pull this one out a little bit more to make it a little cleaner. And I can do the same thing on the other side for this piece, like this, and then add dimension, right click, add dimension of this piece over here, like that, like that, like that. Once again, I can choose any two bolts from this one and just close it up, and then double click on this one and turn it into a tail dimension, like that. And to give the vertical position of the bolts, I can just choose any one of these, select this point, this from the web, this point from the web and the middle of the bolt, like that, 225, and I can double click on the 225 and I can say typical, like that. So basically that would be valid for all of those. And for the, if you want to give the vertical dimension, so now the only thing which is really missing is the dimensions of, because these ones are all centered. And if you come back to the dimensioning rules, it says dimension by bolts, one or two bolts. Do not dimension points which are at the main parts, web or flange, because they're touching the web or flange. So and do not dimension centered parts as well. So since they're centered, I'm not going to dimension them. You can, of course, if you wanted to. but since some things may not be clear, for example, is this plate centered? Is the stiffen end plate centered? And what we can do is we can give a vertical dimension. We can click on the Alt key to snap to any point over there, and click on the bolt like that, and finish it off on the other side like that. So see where that it is actually centered, and do the same for just click on the Alt key to snap to any point like that, and like that. That would basically be, or you can set one more over here as well, or you could leave it. The single parts of each of all these parts have been provided, so we no need to dimension the holes on the main part itself. And basically, if we think about it, we have done what was required. It says add plate annotations to the 3D views as well. So let's do a bit of that. I'll explain the annotating features in some other video, but over here, if you come to the annotation menu, you've got the annotations for profiles, plates, cuts. So if I go into the plates over here and go to the annotation settings, I want the actual part numbers. So that's already there. Otherwise, I could have changed or used custom annotations or something like that. But I want the actual part numbers. That's fine. So what I want to do is basically select this plate and click on this, and I'll get a plate annotation for this one. Like that, I can select on this one and get a annotation for that. And in a similar way, I can continue with the rest of the plates in this drawing. We could, of course, just select multiple plates at the same time, not the profile, say plates like that, or through on-the-fly filtering as well. Just click on the annotation thingy, and we'll just get the annotations, and we could just move through the 3D ones very quickly to do that. So if you notice, we've spent about, and I've been explaining everything as well as I'm doing it. But if I wasn't explaining, I would probably need to spend about 10 minutes, 10, maybe 12, maybe 10 to 12 minutes on the cleanup part, which is moving the annotations around, giving the extra dimensions, adding some more views, maybe cleaning up, maybe taking an extra section, etc. All that could, for a column of this complexity, which is maybe what, if you think about it, it's about 1.1 tons in weight, a little over a ton, could have been heavier as well, but it could have been 5 tons if it was a bigger column, but it could have been slightly lighter as well. But you would spend literally about 10 minutes on the average for these complex, slightly complex things. And that also if you wanted to, because even with just the settings, you can get more or less a drawing which you can issue to the floor. But a good drafting practice should always, in my opinion, include some cleanup, some better representation, because the human eye can do what no software can usually. And so, with that in mind, when you're doing purlins and girts or floor beams or assemblies with 2 holes on each side, you just go ahead with, or simple beams, even main beams. You can just go ahead with whatever the software provides you, because COMOSYS will usually give you a pretty clean drawing to play with. But for maybe about 15 to 20% of the drawings, with a little more complicated, it depends on what kind of work you're doing, of course. But if you're doing very complicated work, then in any case, there'll be a lot of cleanup involved. But with normal structures, maybe about 15 to 20% of your assemblies will need some cleanup. But if you think about it, spending about 10 minutes on each complicated assembly, on an overall sense, will hardly move the line as far as the time is concerned. Or even if it does, the quality which comes with it, and the brand name which you will achieve with it, is perhaps much more important. So the purpose of this tutorial was to show you how to create an assembly drawing with whatever rubbish settings you might have, and then going ahead and changing those settings. Some of those settings, I think we changed about 7 or 8 or 11, I don't know, maybe 10, 12 settings. There are maybe just as many more which you can also change. But usually you will have those settings stored away with some prefix, some name in any case. So that part is just going to take you 1 second. It's the cleanup part which can take anything between 0 to 10-15 minutes, like I said, depending on how complex um the geometry is. But once you understand the procedure for the more complicated cases, the easier ones will stop. Obviously, the whole process will become less challenging for you, and your mind will kind of understand it, and you'll be ready for it mentally. So as you can see, after spending about 10-12 minutes extra on a reasonably complicated column, we've got a very nice looking drawing, very nice looking single parts over here, very nice looking main views, well dimensioned, everything quite easily understandable. Once again, the single parts are beautifully dimensioned. You've got 3D views with all the annotations, um, showing exactly which plate has which part mark, and with a little bit of an effort, like I said, we've produced a drawing which can be sent to the floor, and the floor can just directly get on with its job.